Action.
So, good day. So, today we are presenting our final project. So, our topic is motorcycle part sale analytics, and our business name is Iron Rod Motor Repairs Industries. So, our project is highly feasible because the motorcycle part sales naturally fit a star schema data warehouse design. So every transaction can be organized around key businesses. So questions such as what product was sold, where it was sold, when the sale happened, and who made the sale. These elements became the dimensions that support the efficient reporting and analysis. So our actual data source came from Kaggle public datasets. We use it as a reference for our 5,000 transaction records, covering the most recent 3 to 5 years. So to ensure our simulated data is realistic, yeah, we use Kaggle. And as a reference, this data sets provides realistic product categories like tires, helmets, brake, components, engine oil, batteries, and chains, and along with result pricing information. So next is our business description. So Iron Route Motor Repair Industries isn't just a small local garage anymore. We are a premier nationwide distributor of motorcycle parts and professional mechanic services. We've been operating successfully for 24 years, scaling to a massive network of 45 branches and over 5,200 personal employees. So our motto is we have everything for everyone. So whether a customer is modifying a premium 1100cc superbike or just bringing in a commuter scooter for daily maintenance, we handle it, but because of this, our daily operations are highly complex. So a typical transaction here is rarely just scanning a barcode at checkout. A customer might buy several aftermarket parts and have those parts immediately installed by our in-house mechanics and then pay using a finance installment plan. So the problem and our management concern is, so behind the scenes, we are managing a massive supply chain with multiple deliveries a day just to keep a high demand in parts, so like brake pads and synthetic oil on the shelves. As you can imagine, as the company has scaled, the executive board realized we outgrown the basic operating tracking and we are at a point where we needed advanced data-driven analytics. So management came to us with some major concerns. So they need to track exactly which mechanics and cashiers are driving the most service throughput, and our supply chain managers need to stop stockouts without over purchasing inventory that just sits there losing value. So the key decision for this project was to design a database architecture that could untangle all the messy and real-world transactions. So we map out all the business rules. So for example, is that a branch may employ one or many employees, or an order must contain or one or many lines. So to handle this, we designed also a 11 specific entities, which 8 of them are the core entities, which branch, employee, customer, category, so on and so forth, and associative entities like supplier, product, order line, and order employee, and this is our ERD. And to make sure this data is actually reliable for management, we put the entire architecture to a strict to a strict normalization process all the way to the third normal form. Next section is relational model. So the relational model is the creation of our database and tables. So from the 11 entities, we created the 11 transaction records. We just created from referencing our Kaggle from my Kaggle data set and and made our own. So for the relational model, so it's the process of where we imported those 11 CSV files from MySQL Workbench, and this is all the This is all where the SQs are being brought to life. So next part is the data warehousing and data mining. So firstly are the management questions. So the data warehousing and data mining section is the structural database work we just talked about. This is exactly why we did it. So the executive board doesn't want to look at primary keys and bridge tables. They want answers to critical business questions. So we designed our data warehouse to extract those answers across four main pillars. So first is revenue and branch performance. So in summary, we can now instantly see which of our 45 branches is generating the most revenue, track our enterprise-wide monthly growth, and identify exactly which product categories are driving our sales volume. And second is labor allocation and employee productivity. So instead of guessing who our top performers are, we can pinpoint exactly which mechanics handles the highest volume of service work and which cashier process the most monetary value that's let us optimize our staffing and reward productivity. The third is customer behavior and transaction analysis. So for this part, we can identify our most valuable VIP customers by lifetime spent, track the most popular payment methods, and map out exactly what time of day and days of the week we are busiest. And finally, we have inventory logistics and supply chain. So the data warehouse allows us to catch critical stockouts before they can happen. So we calculate our true margins on aftermarket parts and hold suppliers accountable by tracking their average lead times. The next part of the data warehousing and data mining is the analytical reports. So we run we run the So the analytical reports are the answers or result based on the 20 management questions, and we're gonna branch to each one. So let's start with the revenue. So I'm gonna explain the summary to the each question to each part of the analytical report. So revenue and branch performance again. So starting with the revenue, so the Fairview branch is our undisputed leader, pulling in over 3.15 million enterprise-wide, and our finances are incredibly stable. We consist hit of baseline of roughly to 1 to 1.1 million monthly sales throughout 2025. What is driving this tires and volume is our tires and tubes that dominate our sales by a massive margin, hitting a 6.13 million with the Mission Pilot Sports 5 being our single highest grossing product. Interestingly, while Fairview has the highest total volume, the Cagayan de Oro branch actually has the highest average transaction value at over 2,500. So, next part is the labor allocation and employee productivity. So the summary is so we no longer have to guess who our top performers are, and the data shows that the mechanics, the mechanics, Juan Cruz and Jose Santos, tying for the highest volume of service orders, and when we look at the branch efficiency of Angeles City, takes us top spot of operating with the most productive staff enterprise-wide, but the data also shows where we need to improve. And our reports our reports successfully flag specific underperforming employees who fell below our baseline threshold of 50 transactions. This gives management exactly the concrete data they need to target training or restructure shifts. Then third part is the customer behavior and transaction analysis. So the summary for this one is on the customer side, we can clearly identify our VIPs, which is Ferdinand Corpus is our highest lifetime spender at nearly 53,000, while while Cheryl Tolentino is our most frequent repeat visitor. We also map out at our operational peaks. If you want to know when we are busiest, the data points clearly to midday and late afternoon rushes, with Fridays consistently generating our highest average sales per transaction. And when customer pays, video credit cards are the most frequent choices, followed very closely by digital wallets like Gcash and Maya. And lastly, the inventory logistics and supply chain. So The national so looking at the inventory and supply chain, the national capital region is consuming the aftermarket parts at a massive scale, over 4,800 parts sold, dwarfing other regions. Because of that volume, our low stock alerts are critical. So the system successfully flagged the Dunlop TT900 TAR as a critical risk with only 10 units left. But the good news is our supply chain is holding up well. Like suppliers like Motolite are not only providing great variety and excellent profit margins, up to 1,200 per unit on specific TARs, but our overall average suppliers lead time for high demand items is a highly efficient 1.34 days. So for the next section is the evaluation of the operational database. So while our current operational database is perfect for day-to-day tasks like ringing up customers and logging mechanic tickets, it actually presents a major roadblock for enterprise analytics. So the problem is that our data is highly normalized, meaning it is spread across many different tables to prevent redundancy. But if management wants a simple revenue report, the system has to stitch all those tables back together. So this is a slow and heavy. In fact, if a executive runs a massive lifetime sales report, it can actually freeze the system for our cashier workers on the floor. Furthermore, our current setup only captures the current state of the busiest, making it incredibly difficult to track historical trends. Plus, it's way too complex for non-technical managers to use without asking IT to write custom scripts. So the clear solution the clear solution is to build a dedicated data warehouse by extracting our daily data into a simplified star schema. We can pre-calculate all the heavy math, eliminate those complex data joins, and finally give the executive board fast self-service business intelligence without slowing down on our daily operation. So which comes to the next part is the data warehouse planning. So for our data warehouse planning, so we select a business process. So the core business process selected for dimensional modeling is a retail parts sales and service operations. So it captures the fundamentals, economic events of the enterprise. So a customer buys a motorcycle part, we it requests a maintenance service, pays for pays for that transaction, and has the job fulfilled by an employee at a specific branch. Tracking this process is critical for answering all key management questions regarding revenue, productivity, and inventory health. Then define the grain. So one row in the fact table represents a single line item within a specific customer transaction process at a specific branch on a specific date and time. So the identity measures is the quantity sold, line subtotal, total order amount paid, and stock level drop. So so the identified dimensions are dim date, dim branch, dim product, dim customer, and dim employee. And the next section is the from the data from the from the data warehouse and planning from the four dimensions parts. Then we have the star schema. So as you can see in our star schema, we place all these measurable numbers in a central fact table. Surrounding it are our five-dimension tables, the date, branch, product, customer, and employee. So in simple terms, the fact table holds the what and how much, while the dimension tables give us the who, when, where, and why. So this streamlined, their normalized design is the exact engine that makes lightning fast executive reporting possible. So next part is the ETL process. So now let's talk about how we actually get the data from our live system into this new star schema. So we do this through the process called ETL. So which stands for extract, transform, and load. So first is the extract phase. We pull the records from our 11 operational tables and move them into a temporary staging area. The key here is that we do this safely behind the scenes, ensuring we never slow down the cashiers or mechanics who are actively using the live system. So next is the transform phase. So real world data is messy, so we have to clean it before analyzing it. So we strip our hidden computer characters, remove duplicate to prevent double counting our revenue, and break down complex order timestamps into simple readable categories like year, month, and hour. And finally, we have the load phase. So we load the clean data into our warehouse. So we always populate our five-dimension tables first to generate fresh, simplified ID keys. And once those are set, we load the central fact table last, locking in all our calculated business metrics. And with that, our data is clean, structured, and ready for instant executive reporting. So this is the ETL extraction, which we have done on MySQL Workbench. So first, we created the tables first for each one. So detail process. So we load the table first and create the table for each one. Then do the ETL and the extraction, which we can export the the tables for each dimensions from the star schema. And that's the ETL process. And next part is the data warehouse analytics. So for the OLAP queries, so we put our newly built star schema to the test by executing the 15 advanced OLAP operations directly against the data warehouse. So instead of basic queries, we use multi-dimensional analysis to answer complex business questions. So we started with roll-ups and drill downs, aggregating our total revenue by year and then drilling down into the specific regions and branches generating that profit. And next we slice and dice the data cube and we slice the metrics to isolate specific dimensions such as weekend sales activity and performance of certified mechanics. And we also dice the data to look at multidimensional intersections like tracking the exact value of tires and tubes sold in quarter one. And finally, we have executive rankings and trends, identifying our our five lifetime value customers, 5-time lifetime value customers, and mapping our month-over-month revenue and inventory depletion. These 15 queries prove that the backend architecture is fully capable of handling complex executive data extraction. And now we move on to the dashboard the where those six exported files from the ETL extraction process came to be and are imported on the dashboard. So I'm gonna move the presenter to Mr. Jotsandu.
Thank you very much, Geoffrey Estrella.
You please share your screen so we can see the dashboard.
Kita screen ko.
Yeah, your screen is visible.
Okay. So thank you, Geoffrey Estrella, for the explanation earlier. And I'm proud to present the Executive Summary Performance Dashboard for our motorcycle parts and service enterprises, Iron Brute. So before diving into the metrics, it is vital to discuss why we moved our data from operational transactional database into a structured star schema data warehouse. Our original operational system was designed for day-to-day transactions. However, when trying to extract complex analytical business insights, we faced heavy operational limitations running multi-table joins on a large data subsets that slowed down our reporting significantly, made historical analysis is highly complex and bottlenecked our active database. So to resolve this, we extracted, transformed, and loaded our transactional data into a star schema data warehouse, centering around our fact sales table and branching out to our dimensional table, branches, customers, products, dates. So this allowed us to build a highly performant, fully interactive executive dashboard in Tableau. So the main table is the fact sales CSV, and these are the branches. It's the name, product, employee, date, customer, and branch. So all of these are connected to the fact sales, and this is the updated version of the table. So per our design blueprint, we engineered 10 distinct key performance indicators to give an instantaneous health check of the business. Let's walk through our verified baseline numbers for the standard physical cycle. So this is the total enterprise revenues is standing on 16,086,560 pesos, representing our primary financial intake from all parts and distribution and services. And next is total parts sold. That is 15,026 units of motorcycle components, tires, and lubricants. So this is the total cash collected, and our branches safely logged and finalized 16,086,560 is the same as the enterprise revenue is the total cash that we collected. And next is the total shock depleted and calculated as per invoice, giving us the strategic benchmark of 15,026. And the number of branches is 10. We have 12,500,2,500 unique customers. We have 1,848 employees. Average order value is about 3,200,017.31 cents. And the highest single transaction is 14,750. And the total product category is 5. And these are the visual revenue trends from January until December. This is revenue by region: Central Luzon, Northern Mindanao, Davao, Western Visayas, Calabarzon, Central Visayas, and NCR. This is the top five selling products from highest to lowest. And this is sales by employees or retail cashier. And the second highest and certified mechanic is the highest total order amount. And the third, lastly, is the branch manager. And this is the inventory depletion by category. And now this is the total dashboard. So the monthly revenue trend line chart that is here. This tracks macro level revenue over the physical periods. It lets management isolate historical anomalies, cyclical downturns, or promotional spikes over the calendar months. And the second is the branch revenue performance base. Positioned on the left, this horizontal bar chart quickly isolates on our top performing storefronts. For example, we can immediately evaluate how top branches compared against smaller provincial locations. Third is employee role pie chart. This chart breaks down the revenue distribution across job fields. We can see precisely how much revenue is generated by our certified mechanics, labor, to retail cashiers driving our parts turnover. And that's it. That's our full data for our motor parts performance metrics executive summary. This is the whole dashboard. The filters are working as you can see. And the total amount of order, the colors, all are changing. And that's it. Thank you for your time.